Okay, so good evening all. Welcome back to the 12th and last week of TA live sessions for AI SMPS. First of all, can any of you confirm if I'm audible and is the screen visible? Okay, thanks for confirming. Welcome to the last TA live session. And this week we'll be discussing some questions from the last week, which is week 12. Um, and towards the end, I'll also cover some of the doubts that have been coming up recurring, like in several live sessions. So I'll try to cover those as well. And yeah, so without further delay, I guess we can get started. Okay. So yeah, let's get started. And this is the first question in front of you. So here we are given a crypt arithmetic puzzle. It's essentially an arithmetic problem in which the numerals or the numbers, they are replaced by letters. Okay, there is a one-to-one mapping between a number and a letter or an alphabet, and that's what is also given over here. Each numeral has a distinct letter assigned to it, and each letter stands for a unique numeral. Okay, so there's a one-to-one mapping between one alphabet and one number. Okay, and every number begins with a non-zero numeral. Okay, that our task is to find appropriate mappings between the alphabets and the numbers such that the given equation or the condition is satisfied. So the example that you see here is it's like a toy example, kind of giving you an intuition behind what kind of problems you might encounter, or a small scale of what kind of problems you might encounter when you try to solve. Hello? Yeah, is there a doubt? I can't hear you. Um, yeah, I think your voice is breaking. Sorry for that. Um, yeah, I think your voice is breaking. Maybe you can try rejoining, or you can type in your question. Am I audible to others, or uh, hello? Am I audible to others? Okay, I'm assuming that I'm audible to others. If not, please let me know. Is it better now? Am I audible clearly now? Okay, let me try something. Okay, I hope my audio will be a bit better now. So yeah, sorry for the disturbance in the audio. I think it's just a result of poor connectivity because of the thunderstorms that have been happening in Chennai. So yeah, I hope it's better now. If not, please let me know. Okay, great. Yeah, so coming back to the problem that we had, we have a crypt arithmetic puzzle over here, and our task is to find the one-to-one mapping between the alphabets and the numerals. Okay. So here we are given an example. Okay, jab plus jab equals good. So each of these alphabets stands for some number, and this number has to be non-zero. Okay, and this number has to, and this assignment has to be there in such a way that this equation is satisfied. Okay, so before we move on to this one, let's try some simpler examples first. Okay, so do any of you have any potential solutions in mind for the left hand side equation that is given over here? Okay, so we have a plus a equals cd. So does anyone have any solutions in mind for what could be the numbers assigned to a, c and d? Okay, but remember we are given a condition that the numbers have to be non-zero. Yeah, so each number assigned to each alphabet should also be non-zero as per the question. So maybe we can assign a number greater than 5 to a. Exactly. So this is one possible solution. There could be many others. There could be 7, 8 and 9 as well. Right? Anything more than that would be difficult, because then we would have to have more than the number of digits given in this equation, right? So there are several solutions possible. There can also be cases where there are no solutions possible. So does anyone have any potential solution for the right hand side equation? So here one hint is that the starting digit of both if and it has to be the same. Okay, any guesses? One more hint is that you need to have such assignments that allow you to have 3 digits on the right hand side and 2 digits each for if and it on the left hand side of the equation. Okay, so I'll give you one hint. Maybe let's assign 9 to the alphabet I. Can you come up with assignments to f and t that satisfies this equation or satisfies the constraints given to us in this equation? Okay, so we have a potential solution in the chat box. F equals 2 and t equals 3. Let's try that out. If f is 2 and t is 3, what do we have over here? We have 5 over here and then 1 8 over here. So this works, right? Exactly. 82 plus 82 equals to 164. Okay, that's also a possible solution. No, that's not actually a valid solution. Yeah, because you are assigning f and t the same letter, but we can't do that. There has to be a one-to-one mapping. So each letter must be assigned a unique number, and we can't assign the same number to multiple letters. So you're going in the right direction, but yeah, just keep the constraints that are given to us in mind. So the reason behind we are discussing this problem is to give an intuition behind constraints when we are trying to solve a problem, right? So these are the different constraints that are given to us, that each letter has to be assigned to only a unique number, and each number should be a non-zero entity, right? So you can try and think of some other assignments as well. 93 plus 92 can also be a possible assignment, right? Although that will give you the same answer on as to y, that is 185, I think. But yeah, you can think about the other solutions as well. But let's go back to the problem that we had, which is jab plus jab equals to good. So can you think of any assignments to satisfy this equation jab plus jab equals good? Okay, we have an answer in the chat box, but I'll okay. So that's just we good attempt, but then again I'll remind you that on the right hand side we have good, which has GOOD, but based on your solution, O has two different numbers assigned to it, which is also not possible, right? Each number should be assigned to a unique alphabet, and each alphabet should be assigned to a unique number. That's right. G has to have the letter 1 if you think about it. So, yeah, so I'll let you think about it for a minute, and then we can try and come up with some solutions to the complete problem. Okay, so we have a couple of more solutions in the chat box, but then um, let's discuss those one by one. So one of them is 612 plus 612, right? While it seems to work, but then again you have to be careful because you are assigning the letter A at the number 1, and then you are also assigning the letter G the number 1, right? So that is not valid. So 612 plus 612 will not work. 632 plus 632, let's think about that, will give us 1264, right? So that will also not work because O has been assigned two different numbers in that case. 632 plus 632 would be 1264, and yeah. So I'll give you one hint. um, I'll show you one possible solutions, and then you can think if there are any more solutions that we can come up with. Okay, so think about this. 723 plus 723, that gives us 1446, right? So in this case, each letter is assigned a unique number, each number is assigned a unique alphabet, and all the constraints are also satisfied. Okay, Tejasvi, again I'll remind you with one of the constraints that is given in the problem. We should assign non-zero numbers to the alphabets, right? So 503 and should not work. Can you think of something starting with 800 or 900? Okay, so this is one more possible solution. Okay, does these two give any hint of some number starting with 900 to be assigned to jab? Yeah, that's right, Roji. 723 plus 723 is a possible solution. So Shiva Krishna 941. Let's check. Almost there. So 943 should give us the answer. If we do 941, then that will give us 1882. But in that case, the problem is that you're assigning 1 to both B and G, right? So yeah, if you move to 943, that will solve the problem for us. And if you think about it, these three are the only possible solutions that we can have to this particular problem that is given, crypto arithmetic problem that is given to us. Any other solution will violate at least one constraint that is given to us in the question. Okay, so the basic idea behind this question was, like I said before, to motivate you about different constraints that you might have to handle in constraints solving problems. Okay, CSPs essentially. So I'll let this be here for a couple of seconds, and you can convince yourselves that these three are the solutions before we move ahead to answer the questions based on this problem. If there is any doubt, please feel free to let me know. Tejasvi, yes, 613 plus 613 would violate the constraint that you are assigning number 1 to letter A as well as to letter G, right? So that's why this solution is not acceptable. Okay, so problems like this, they are actually something that you have to do a bit of a hit and trial. Okay, you have to look at the characteristics of the equation given, like you see that there are two O's in the right hand side of the equation in good, right? So those two have to have the same number, and you need to have the letter or the number 1 assigned to the first alphabet on the right hand side, which is G, right? So if you think about these small things, try to decompose the problem into small bits, it would be a bit easier to do the hit and trial approximations and come up with a solution. Okay, so 976 is another potential candidate in the chat box. Let's look at that. That will again lead to 1952 as the sum, right, which is assigning different numbers to the letter O, so that won't work, right? Yeah, so these three are the solutions given to us for this constraint satisfaction problem. Okay, so I hope this is clear, and let's go back to the questions based on this problem. Okay, so the first question is, does the above puzzle have a unique solution? So let me clarify. What we mean by unique solution here is that, is there only one possible mapping between numbers and alphabets that can give us a appropriate solution? That would be no, right? That is what the question asks. Does the puzzle have a unique solution? No, because we can have multiple assignments of numbers to alphabets, right? So the problem does not have a unique solution. Oops, let me try to refresh this. Yes. So does the above problem have a unique solution? The answer would be no. Okay, because we just saw there were three possible solutions. Is the value for the letter G unique for the above puzzle? And if so, what is that value? Right, based on the three solutions that we just saw, what was the value that we assigned to G in this case. That's right, it was 1, right? So there was a unique value assigned to the letter G because of the way the constraints were given to us, and that value was 1. That's right. So thanks for the solutions to all of those who put it in the chat box. So question 3 says that is more than one value possible for the letter J in different solutions. So the first letter, that's right, more than one values for J is possible, and we just saw that J can take 7, 8 and 9 as the values in different solutions, right? So the answer would be yes. Okay, I hope this was also straightforward. Now let's come to the fourth question, which says what can we say about the value for the letter D? Okay, so D is the last letter on the right hand side, right? D, and the value of D is dependent upon the value that the letter B takes, right? Because we are going to add B, and the solution for that is going to give us what value the letter D might contain. So can it be an even number, can it be an odd number, or can it be either of them? What do you think? That's right. So one solution, or okay, multiple solutions in the chat box, so it can be an even number, which is correct, because irrespective of whether B is assigned even number or an odd number, the sum of both of these will always be even. Okay, so if B is assigned an odd number, the sum of two odd numbers will always be even. If B is assigned an even number, the sum of two even numbers will also be even. So D will always be even. Okay, there's a similar question in question 5, which says that what can one say about the value for the letter O? So based on a similar reasoning, what do you think will the value of O be? Will it be odd? Will it be even? Okay, so there are multiple solutions in the chat box, and they all say that it will be even number, which is correct. By the same logic that we just saw in the previous question, O will also be even. Okay. So these were some of the questions that were based on the cryptarithmetic puzzle. I hope they were um, clear. Yeah, is there any doubt? Uh-huh. Okay. Your voice is breaking again, but I suppose I got a part of your question which says that B could be assigned the value 5 is what you're saying, right? Okay. So mm-hmm. Okay, so when B will not be assigned a value 5, I think, because then D would have to be 0, right? And one of the constraints prevents that. If it is 6, okay. Yes. Yes. Mm-hmm. That's right. Um, Shiva Krishna, I think, thanks for your inputs. I think there's a background noise in your audio. But yeah, thanks for your inputs. So yeah, let's think about it. let's go back to the problem setting given to us to deal with whether to like understand whether the carry case is something that we have to consider. Okay. So it says that each numeral has a distinct letter assigned to it, and each letter stands for a unique numeral. Every number begins with a non-zero numeral. The task is to find out whether each letter stands for what each letter stands for, and so that the arithmetic problem has a solution. Okay, so we're not given any specific information about the carry task. So if we come back, if we have, let's say, 6 assigned to B, like let's say what was one of the solutions suggested in the chat box, which is 976 plus 976. That will again lead to O being odd, but then that will also lead to O having two different integers assigned to it, right? So that will also break one of the constraints given to us. So I think the constraints given do take care of that. Is there any other assignment that will allow us to maintain the constraints as well as assign an odd number to O? Can you think of something? So just you have a question, please go ahead. Sudhishta, you are not audible. Okay, so I'll just repeat the constraints that are given to us. Okay, so the constraints, the first constraint that is given to us is there is one letter, one unique letter that is assigned to one number. Okay, and there is one unique number that is assigned to one letter. Okay, so there is a one-to-one mapping. The number that is assigned has to be non-zero. Okay, so and then the third constraint is the equation itself. Okay, the number of digits on the left hand side and the right hand side should be appropriately assigned. So these are the constraints given to us, and thanks for pointing out the carry issue, but I feel that the constraints given will handle the different edge cases. If not, you please let me know, then we can think of different possible solutions, and in that case the answer would change. But as of now, I think that this seems to be okay, in that the letter O will be an even number if we maintain all the constraints. Okay. Okay, sir. Yeah, thanks for your query. So Dishta, I hope this clarified your doubt. You are still not audible. I hope it did. If not, please let me know in the chat box. In the meantime, I'll introduce the next question, which is based on a slightly different kind of CSP, or a constraint satisfaction problem. Okay, so here we are given three variables, x, y and z. Okay, and each of these take values from a specific domain, okay, or a set of numbers, and the domain is same for all the three variables. Okay, so we denote the domain of x by d subscript x, and the domain of y by d subscript y, and similarly for dc, and the domain is 3, 4, 5 and 6. So x, y and z can take values from 3, 4, 5 and 6. Okay, and there are two constraints given to us. The constraint between x and y is that x should be less than y, and the constraint between y and z is that y should be less than z. Okay, and now what the question tells us, we have to make the network that will be formed as a result of this different constraints given to us. We have to make it arc consistent, and we have to tell what would be the elements that would remain in the domains after the network has been made arc consistent. Okay, and we also have to draw a matching diagram, which we would need in order to find the solution. So I'll just give some introduction about matching diagrams and arc consistency before we move ahead. So You can refer back to the lecture slides if you want to go into the details of what exactly is arc consistency, but I'll just give an intuition. So a variable x is said to be arc consistent with respect to a variable y. So if, so remember this is I double f, so if and only if for every value a in the domain of x, there is a variable b in the domain of y such that a and b are satisfying the constraint between the variables x and y. Okay, so this is basically the condition for variables x and y to be arc consistent. Okay, and then this algorithm can be used to make a network arc consistent by using this revise method or function that is given to us. Okay, in order to solve our problem, what we can do is oops, I think I didn't share my screen with you. So this is what I was telling initially. A variable x is said to be arc consistent with respect to variable y if and only if for every value a in the domain of x, there is a variable b in the domain of y such that a and b, assigning a and b to x and y respectively, satisfy the constraint between x and y given to us. Okay, and we can use this method revise x comma y to achieve an arc consistent network. You can refer back to the lecture slides to get into more details, but in order to solve our problem, we can first represent the domains of the three variables given to us in this fashion, and then we can actually connect the different numbers in each of these domain depending on how they follow the constraints. Okay, so I'll show you one example. Let's choose a different color. Yes, so if we assign 3 to the variable x, okay, then the values in y that will make sure that the constraint x less than y is satisfied. Remember, so one constraint is x less than y and the other constraint is y less than z, right? So 3 and 4 will be connected by an edge, 3 and 5 will be connected by an edge, 3 and 6 will be connected by an edge. Okay, similarly 4 and 5 will be connected by an edge, 4 and 6 will be connected by an edge, 5 and 6 will be connected by an edge, 6 won't be connected to any other element in y, right, because it does not satisfy any other no assignment satisfy the constraints with x being assigned as 6. Similarly, we can draw the edges between y and z as well, and they'll follow something similar, right? So 3 will be connected to 4, 5 and 6, 4 will be connected to 5 and 6, and 5 will be connected to 6 alone. Okay, now based on how we make the network arc consistent, you can try to remove some elements from the domain and see which elements you are left with in the different domains, such that the whole network remains arc consistent, or in other words, you only have elements left in the domain that allow all the constraints to be satisfied no matter which number is being assigned from amongst the different domains. Okay, so I'll let you try to work it out for maybe a minute or so, and then we can try to discuss the rest of the solution. Please feel free to let me know if there's any doubt in the question or in the discussion of the solution till now. Okay, so we already have a solution in the chat box, and that's great. I also think it's correct. So let's discuss the rest of the solution. So so as we saw here, some of these elements in dx were connected to some of the elements in dy, and some elements in dy were connected to some elements in dz. Okay, so we will remove some of the elements from each domain, but we will do it in a certain manner. Okay, let's choose a different color for this. Yeah. Okay, so first we'll move in this direction, okay, which is from x to y. Then we'll move in y to x, then we'll move from y to z, and then we'll move from z to y. Okay, we will remove elements in that order. So let's assign that to it: 1, 2, 3 and 4. Okay, so first in the direction of x to y, here we see that 6 is a number that is not assigned, does not have any edge to any element in dy, right? So we will remove 6. Then so that is the only element that we can remove from dx. Okay, now in the backward direction from y to x, okay, dy to dx, here we see that 3 is one element that does not have any edge to any element in dx, right? So we will remove that. Okay, no other element can be removed. Now we'll look at the direction dy to dz, okay, this direction, and here again we see that 6 is one such element that does not have any edge from dy to dz, so we'll remove that, and no other element can be removed. So now we'll move in the direction from dz to dy, and here we see that 3 is a number that does not have any edge from dz to dy, so we'll remove that. Okay, once we are done with that, let us reconstruct the domains given to us. Okay, so in dx we have only 3, 4 and 5 left, so let's write that down. We have 3, 4 and 5. This is dx. In y we have only 4 and 5 left, and then in dz we have 4, 5 and 6 left. Okay, great. Yeah, thanks for the partial solutions as well, Shiva Krishna and Sudhishta and Sivarama as well. Okay, so we'll repeat the same process again. Okay, let's draw the edges. So 3 will be connected to 4 and 5, 4 will be connected to 5, and 5 won't be connected to anything, right? From dy to dz, 4 will be connected to 5 and 6, and 5 will be connected to 6, right? This is the only possible assignment. And again we see that this number 5 we have to remove because it's not connected to anything, right? In dy, 4 and 5 are connected to something or the other in dx or dz, so we don't have to worry about them. From dy to dz direction, we see that there is nothing we can remove. From dz to dy direction, we can remove this 4 from here, right? So let me erase those parts alone. Oops. Okay, so yeah, so this is what is left for us. Okay, and now we see we cannot remove any elements in any direction from dx to dy, dy to dx, dy to dz, or dz to dy, right? So this is where we will stop, and this is where we know that our network is now arc consistent. Okay, so is there any doubt in the solution till now? Okay, you can try to revisit the revised function that was given in the lecture slides and try to see whether it follows the same process that we just did in the manual solution, right? And you can verify that for yourself. Okay, I hope the solution is clear. Then let's move on to the questions that were given to us based on this problem setting, and we were asked what would be the domains after the network is made arc consistent. Okay, and the answer to that would be, okay, it's not given here, but the answer would be that it would be dx would be containing 3 and 4, dy would be containing 4 and 5, and dz would be containing 5 and 6. Okay, let's go to the next question, which says that for the above CSP, the value of dx after the network is made arc consistent is, okay, so it's just restated in a different manner. It would be 3 4. The value of dy after the network is made consistent, arc consistent, that would be 4 and 5, right? And the value of dz after the network is made arc consistent would be 5 and 6, right? Are there any doubts till now? I hope I'm still audible. Okay, thanks for confirming. Great then. So, okay, now let me show you a certain different kind of question. So unfortunately this question also has the solution along with it, so don't look at the solution first. Let's try to solve it first, and then we can look at the solution. Okay, so consider a map coloring problem, okay, with 6 regions A, B, C, D, E and F. Okay, so these are the 6 different regions given to us in a map. Okay, and we are also given the order in which these regions will be processed. Processed for what? So what we have to do is we have to assign colors to each of these six regions. Okay, and the domain of the colors is RBNG, which stands for red, blue and green. Okay, so we have to start assigning these regions one of the colors from RBNG, and we will move in the order of A, B, C, D, E, F. That is, we will first assign a color to A, then to B, then C, D, E, and then finally to F. Okay, but the constraints given to us is that no two adjacent regions should be assigned the same color. Okay, we are also given which regions are adjacent to each other. Okay, we are given that A and B are adjacent, A and C are adjacent, A and D are adjacent, B and C are adjacent, C and D, C, E, D, E and D, F, these are all adjacent. Okay, so we can actually represent this in terms of a graph. Okay, so we are given A and B are adjacent, so we'll draw an edge between A and B. Okay, then A and C are adjacent, then A and D are adjacent, B and C are adjacent, C and D are adjacent, C and E are adjacent, D and E are adjacent, and D and F are adjacent. Okay, so this is the graph of the different regions depending on the edges. The edges basically represent which two regions are connected or adjacent to each other, and we cannot assign the same color to any two adjacent regions. Okay, so yeah, I'll try to let you solve this. Okay, so what you have to do is you have to assign a color from red, green and blue to each of these alphabets or regions, and you have to maintain the constraint that no two adjacent regions get the same color. Okay, so I'll let you try to solve this on your own first, and then we can have a look at the solution and the questions. Okay. Okay, so right, so one more piece of information that is given to us is the partial assignment. Okay, so assume that you are using the generalized look ahead algorithm with select value forward checking. Okay, this is the approach you have to use for the map coloring problem or the problem given to us, and we have to assume that we are given the partial assignment that A is assigned the color R or red and B is assigned the color blue or B. Okay, so this is one piece of information that I hadn't mentioned before, so let's keep that in mind. Okay, so we know that oops. Actually, let's use this color to denote numbers that we don't want to keep, or denote colors we don't want to keep. So we know that G and B cannot be used for A, and R and G cannot be used for region B. Okay, so this is given to us. Okay, so we already have a solution in the chat box, which is that A is assigned red, B is assigned blue, C is assigned green, D is assigned blue, E is assigned red, and F is assigned red. Okay, let's have a look at the solution and see if it's correct. Okay, I think a better way to denote the absence of particular assigned colors would be through marking them with a, yes, that should work. Yes, so we cannot assign this, we cannot assign this. Okay, now because we assigned red to A, any adjacent region to A cannot be assigned red. Okay, so we know that D is adjacent to A, so we can cross out red from D. We know that C is adjacent to A, so we can cross out red from C, right? And then B is already partial, so partial assignment of blue to B is given to us, which also has the red crossed out. Okay, so that checks out. So now we have assigned a color to A. Now the order which was given to us was that next B will be assigned a color, which is also given to us. After B, C will be assigned a color, right? So because B is assigned the color blue, anything that is adjacent to B cannot be assigned blue, right? So because C is adjacent to B, we cannot assign blue to C. Yes, that is correct. And we also cannot assign blue to A. We already assigned red to A. Okay, so that checks out all the constraints for region B. Now only one option is left for region C. C can only be assigned green, and because C is assigned green, we can cross out green from E as well as D, because they both are adjacent to C. So green cannot be assigned to either D or E. Okay, now in the next order, D should be assigned a color, right? And D has only one option left, which is blue. So D will be assigned blue, and because D is assigned blue, blue cannot be assigned to F, right? And blue also cannot be assigned to E, because they both are connected to D. Next we will assign a color to E. E has only one option left, which is R, so red will be assigned to E. And F has two options, red and green, right? So F can take either of those colors. So this gives the solution to us for the map coloring problem. Okay, I'll leave this on here so that you can convince yourselves about the solution before we move on to the questions based on this problem. Actually, let me show you a more properly put together solution. Okay, right, yes. Okay, so this is a solution that has been prepared by one of the previous TAs, not myself, so I just took that solution from them. And yeah, so this is much more clearer, and here you can easily see that the different steps, right? So first red was assigned to A, and because red was assigned to A, red was crossed out from D, C and B, right? In the next step, then we follow a similar procedure, right? B is assigned blue, so we cross out blue from A as well as C, right? And then we proceed further. We assigned green to C, right? And because we assign green to C, we cross out green from B and D, and then we assign B to D, and so on and so forth. Okay, so this is the final graph, what it might look like. And yeah, so are there any doubts in this particular solution? Okay, that's great. So let's move back to the questions that were given to us. So the questions essentially asked us what colors will be assigned to the different variables. And I think you can just answer that based on the different the whole problem, the whole network that we constructed. Okay, so I'll just leave this on here. This is also available to you in the same drive folder, okay, where all the other live session um, questions and slides are uploaded, so you can refer to that at your own time as well. Okay, so I'll just take a pause of 1 minute, okay, while I get some water, and then we can move on to some of the doubts from the previous weeks. Okay, so to address your doubt in the chat box, Shruti, all the recorded sessions are uploaded in the YouTube channel, and the link can be found through Swayam. Okay, so through Swayam, where the usual problem solving, the usual lecture videos for the different weeks are given. There you'll find a subsection for problem solving session, and you can click on that link. That will lead you to a Google Sheet, and that sheet will contain all the different TA live session recordings from not just my sessions but also from the sessions of the other TA who conducts the sessions on Saturdays. Okay. Okay, so yeah, I'll just conclude the lecture videos or the questions from the lecture 12 content by wishing you all the best for your final exams and the remaining assignment. And yeah, before we conclude the session, I'll just cover some of the doubts that had been recurring in some of these live sessions that we conducted. Just give me a minute. Okay, so this nearest neighbor doubts, greedy heuristic and savings heuristic is something that has been coming up quite a lot. So let's just go over this particular an example for each of these. Okay, okay, so so here we are given a distance matrix. Okay, A, B, C, D, E and F are the different cities, and we have to construct a TSP tour. Okay, traveling salesman problem is what we have to solve. We have to maintain the conditions that each city has to be visited exactly once, and we have to select the minimum cost tour. Okay, okay, so what nearest neighbor does is that, let's say it starts with A. Okay, let me use different color. Okay, let's say we start with A. Okay, it looks at that row, okay, and finds the lowest cost edge. Okay, in this case it's obviously non-zero cost. Okay, you don't want to go from A to A itself, so the least cost edge is this one, right? A to E, which has a cost of 3. Okay, so we will add that edge in our TSP, A to E with cost 3. Okay, next we have to find an edge from E. Okay, so we'll look at the row for E. Okay, here the least cost is A again, okay, with value 3, but we cannot use this again because that will close the loop, right? So the least cost other than 3 is this one, right? E to D, right? So we'll add that. Okay, next we have to find some edge from D. So again in D the least cost edge is D to A, but we cannot use that because that will violate the Tour condition. It will form a closed loop. So other than 4, the next closest edge is 6, but we cannot use that again because that will also cause a closed loop between D to E. So we'll have to go with 7. Okay, so D will be connected to F with cost 7. Next we have to find an edge from F, and here the lowest one is 2, which is F to C. So F will be connected to C with cost 2. Then we have to find an edge from C, and that cannot be this one because then C to F will be closed. It has to be C to B. With cost 5, right? And now we are at the end. Okay, B has only one option, is to go back to A to form the full tour. Okay, with cost 16. Okay, so this is how we apply the nearest neighbor to find the traveling salesman problem solution. Okay, and the path representations could be in either directions, either from let me show you. It could either be from A to E to D to F to C to B and then back to A, or it could be from A to B to C to F to D to E and then to A. Okay, and either of those way you can represent the solution or the path. So this was nearest neighbor. Let's think about greedy heuristic ones. Okay, it's the same distance matrix given to us, and so here what we will do is, as the name suggests, we will be greedy. Okay, we will look at the lowest non-zero cost across this whole matrix. Okay, and that is 2. Let me choose a different color so that it's more clearly visible. Yeah, so 2 is the least cost among all of these, except of course the non-zero costs. Okay, so this is an edge between C and F. Okay, this or this, it corresponds to the same edge. So we will add the C to F edge in our graph. Okay, next, other than 2, which is the least cost edge over here? It's this one, right, with value 3 in the whole matrix. This is an edge between A and E, so we will add that to our graph. Okay, once we have done that, what is the next least cost edge? That would be this one. Okay, which is from A to D or D to A. Okay, so we will add that. After that we have the next least cost edge, which is 5, which is from B to C. Okay, so we will add that. Next least cost edge is 6, which is from D to E, but then this would cause us to make a closed loop, right? And we don't want that, so we will skip DE and we will go for the next least cost edge, which is 7, which is D to F, with cost 7. Okay, and now all the cities have been covered exactly once, and this completes our tour. Okay, so we can go either in this direction. We can connect this back, okay, to make the whole tour completed. Okay, and so we can go either from A to D to F to C to B to E, okay, and then back to A, or we could go from A to E to B to C to F to D and back to A. Okay, so this is an example of greedy heuristic. Okay, and finally savings heuristic. So this is a different distance matrix. Okay, so here I'll just give an intuition, I won't give the whole solution. So essentially what we do is that we look at each row, okay, and for each row we add double edges going from one node to the other. Okay, so here from C to A, the cost is 36, and then from A to C the cost is 36 again. Okay, or let's consider a particular node as the base node. Let's say we considered B as the base node, right? So, and let's draw these double edges from B to A. So B to A would be 50 each. Okay, and then B to C, let's draw. These would be 82 each. Is my voice breaking again? Sorry, your voice, I couldn't hear what you were saying. Is okay. Is it better now? Okay. Yeah, I think it's just a result of the poor connectivity. Yeah, sorry for that. But yeah, we are almost done. So I was just telling you about the savings heuristic. So here what we do is we take a particular node as the base node and we construct these double edges, okay, for the different nodes other than the base node. Okay, so we constructed for A and C, we can do the same thing for B and B to D, B to E, B to G and B to F. I'm not drawing that to save clutter. Okay, next what we have to do is, if we want to add an edge between A and C, right, we would incur a specific savings, right, and that saving will essentially be computed as so we will remove one of these edges, one of these and one of these, and instead we will connect A and C, right? So the savings for adding the edge A to C would be 50 plus 82, because we are removing 50 from A to B, we are removing 82 from B to C, and then we are also if we add A to C, that would incur a cost of 36, right? So this will give us a particular value that would be the saving corresponding to adding the edge between A to C. Okay, similarly we can add the edge between A to E, A to D and A to G and A to F, right? So what we will do is we will find the saving value corresponding to each of these possible potential edges, and then we will choose the most promising looking among them. Okay, and that is how the saving heuristic proceeds. So this is just an intuition behind the saving heuristic, and yeah, I hope this addresses some of the recurring doubts that kept coming up in the previous live sessions, and they are helpful. So yeah, so that's it from my side. Okay. Okay. Which one? Okay, just give me a minute. Group 3, okay. Okay, how many? Okay, okay, how did you proceed to solve this then? Mm-hmm. Okay. Okay, I can try. So it tells us how many full solutions exist, right? Um, okay. Did we discuss something along similar lines? Let me check. Yeah, it's just taking a while to load. Just bear with me. Mm-hmm. Okay, we didn't discuss something exactly similar to full solution or full decomposition. Okay, so what it seems to me is that um, so there are different ways we can find the decomposition, right? Which may be optimal or non-optimal. It seems like this corresponds to how many different decompositions could exist, whether optimal or non-optimal. I am not sure whether I am entirely correct on this, but yeah, that's what it seems to me is the case. We have to solve the whole thing in order to understand fully how 9 is coming up. So did you try something similar for that? Mm-hmm. Okay. Okay. And that also didn't resolve the query. Okay. Okay, we can try looking at it. So here we starting from 10 and okay, from S we can either go in this direction. Okay, let me do one thing. Why don't I try solving it myself first, and then I can, if I'm able to find a solution as to how 9 is coming up, I can post it in the discussion forum. Okay. Um, because so actually I also have to revisit some of the concepts of A0 star. I am getting a bit confused, so I want to do that before I try to attempt it, because then I would propagate my mistakes to others as well. So yeah, I'll try to do this and I'll see how 9 is coming up. If I find, I post it in the discussion forum. If I don't get 9 as well, I will contact Bhaskaran sir and tell him to maybe provide a proper hint to that. I think some of you might have already asked Bhaskaran sir, and he probably couldn't give a complete hint. But yeah, I'll see how this can be resolved. Is that okay? Okay. Thanks for your doubt. Yeah.
Sir, quiz 5, question number 3, sir.
Which one?
Quiz 5, question number 3. Quiz 5.
Okay. It's the same thing that we. Okay, what is this? Branch and bound. Uh huh. Okay. Okay, so again for this, we'll have to try to solve the whole thing, and I need to brush up my uh, concepts on BNB again before I attempt it. So, have you posted this doubt in the discussion forum, and has Bhaskaran sir addressed it in some way? Khalid, sorry, your voice got interrupted. Hello? Okay. So I was just asking that did Bhaskaran sir give any hints to this? Did you post this in the discussion forum? Okay. Okay. So I'll address, yeah, I'll address this one by one. Uh, so first, regarding your posting to the discussion forum, I would suggest that along with your query, you also post some partial solution, because I have noticed that Bhaskaran sir is more helpful, as in he's able to help more properly if you have a partial solution at hand as well. Otherwise, it's also difficult for him to pinpoint where you are facing the problem, right? So I'd encourage you to give a partial solution as well. And then regarding the duration of the exam, yes, I think it's 3 hours. But whether you'll have a time limit for each question or not, I am not sure, because I am not involved with the question preparation or the examination logistics in any way. So I would also encourage you, either one of your colleagues, if they know about it, they can help you out, or if not, you can write a mail to the NPTEL team, or even in the discussion forum you can post a separate query about the duration, as well as the duration of the whole exam plus per question. Okay, so yeah, unfortunately I don't have information on that, but I can point you to the different sources where you can find your help on these questions. Okay. Anything else? Okay, if nothing, then um, yeah, Tejasvi. So I am not aware of what WhatsApp group this is about. You can maybe get in touch with your colleagues to get to know about this WhatsApp group. But again, I would say that the discussion forum is what I prefer to get the doubts clarified. Okay. Um, okay, then if there's nothing else, then yeah, all the best again to all of you. And yeah, all the best to all of you, and do well. All the best for not just this exam but all your future endeavors as well. I hope the live sessions were of some help, and yeah, um,
Sir,
yeah,
the live sessions were of great help, sir. Thank you
okay.
so much, sir.
Thank,
Sir,
yeah, thanks for your kind
sir,
words. Your voice is breaking, I'm afraid.
whatever problems we have, whatever works we have, you just push it and we comment section.
uh,
Comment your sessions.
Okay, so that's very kind of you. Thank you for your kind words. Yeah, I enjoyed taking these sessions as well, and yeah, I hope all of, not just the people who could attend the session, but who watch the sessions later on. I hope it's of some help to them as well. Um, So yeah, thanks all for attending for all these weeks, and yeah, maybe we'll see each other again in some other course. Okay, then I'll end the session. Have a rest. Have a rest. Have a good rest of the evening. Okay.